So the Hamiltonian cycle is technically a special case of the traveling salesman problem, where you have like a bunch of cities and you want to be able to only visit each city once and get there is the minimum amount of distance or the minimum amount of time or something like that to optimize your traveling approach. So one of the ideas or one of the things of interest is, particularly if you have a complete graph, can you find a low weight spanning cycle of that graph? So finding the lowest weight spanning cycle is not exactly something we can do, but we can find one of low weight. And there is an algorithm to find the one of low weight. So it's not the lowest weight, just a low weight. So the algorithm is basically you find a minimum spanning tree for your complete graph. So step one, you find a minimum spanning tree for your complete graph. And then what you do is you look at this minimum spanning tree. So you're looking at the spanning tree and you perform a depth first search on it. Perform a depth first search. And then what you do is your visitation in your depth first search is creating a low weight Hamiltonian cycle. So say your depth first search gives you an order of V1, a transversal order of V1, V2, V3, all the way to Vn. Then your Hamiltonian cycle is going to just take that and add that V1 at the end again. So what you do is you find a minimum spanning tree for your complete graph using any algorithm or method of your choice, that is Prim's, that is Kruskal's, any of those, and then you take that spanning tree graph and you perform a depth first search on it. And then you take that transversal order and you just add, the one that you begin with as the one you end with, and that gives you a Hamiltonian cycle of low weight. Okay, so that is how it's going to approach it. So let's do an example. Okay, so let's do an example. So let's quickly just draw a graph that we can utilize for this to find a low weight spanning cycle. It's going to be one of those basic graphs. It is a complete graph, because remember, this is only going to work for complete graphs. So we have A, B, C, D. Let's add the edge weights to this. 1, 1, 1, 2, and 4. BD is 4. Hold on, wrong thing. So BD is 4, AD is 2, and we have 6 up there. So step 1 is to just find the minimum spanning tree using any method of your choice. I'm going to use Kruskal's. So I look for my weights of minimum. I look for my edges of minimum weight. So it's BC, CD, or AD. So I add BC first. Don't know what happened there. BC. Okay, then we look for the next one. So I added BC. We look for the next one, and I'll add DC. That's one, and that's one. Bring your weights across with you. And then I look for minimum weight, and I add AD. Okay, so now we have a minimum spanning tree. We're now going to perform the depth first search as the order you go through. So you perform a depth first search on this. So you can select any vertex and go from there. So I'm going to choose D. So I start at D, so it goes D to A. Then we have to backtrack, and then it goes D to C, and then it goes C to B. So that is going to be my transversal order for my depth first search in that case. And then we have to look at our our cycle. So our cycle is, we add D again here. Okay, so that's how we get to our cycle. And now we've determined the weight of our cycle. We say, okay, well, we have DA, we have AC, we have CB, and then we have BD. DA is 1, AC is 1, CB is 1, BD is 4. So we're going to end up with a length of 7 in this situation. So our cycle length is 7. We could have also selected a depth first search utilizing, say, C first. So if we utilize C as our starting vertex, we would have had CB, we would have then had CD, and then DA. And what we would have done here is we would have added C for our cycle, but then we would have had CB, BD, DA, and AC for our length. So we would have had 1, 1, 1. Let's just do it like this so you can see it's all added together. Plus AC, and AC in this case is 2, which gives us 5. So you'll notice the technique is not going to give us the lowest necessarily, but it is going to give us a low weight cycle. Okay, and that's pretty much it. This is how you do the method. So again, it's going to give you a low weight. It's not going to give you the lowest.